Welcome back to the 20th part of Debugging at Scale, where debugging is sometimes like playing with Legos. When tracking a bug, we need to take a two-pronged approach, similar to tongs that wrap the buggy module from both sides and squeeze to find the problematic part. Up until now, we discussed tools that are very low level. Some can be used to debug system-level services. Today, we'll discuss the other side of the stack, but still a very advanced management tool. To understand this, you need to understand the field we're in. As developers, we deal with code and applications. Deployment is for ops or DevOps, and the tooling they use is often alien to us. It's not that they have bad tools. On the contrary, they have amazing tools, but they're usually designed for massive scale. When you need to manage thousands of servers, you need a way to control things in all of them. For that, we need a different set of tools. Management tools let us traverse through clouds of machines and manage the applications running on them. We don't always need the scale that these tools provide, but the management capabilities are a powerful tool that's very useful for developers. There are some standards that implement application management. Java introduced JMX, the Java Management Extensions, to encapsulate their differences. JMX lets applications and the JDK itself expose information and functionality to manipulation by external tools. This is a remarkable feature that exposes information and tuning levers for dynamic manipulation in runtime environments. Activating JMX is outside the scope of this tutorial, so I won't go too much into details, but you can check some of the basics in this Oracle article. Once we have this running, we can use visual tools to debug, but I'll focus on command line tooling. This is important since I can use some of this tooling directly on the production servers right from the console. JMX exposes management beans, MBeans. These are objects that represent control points in the application. Your application can publish its own beans, which lets you expose functionality for runtime monitoring and configuration. This is very cool, as you can export information that an administrator can wire directly to the dashboard, APM, Prometheus, Grafana, etc., and use that for decision making. If your server has multiple users connected concurrently, you can expose that number in JMX and it can appear in the company dashboard thanks to some wiring from DevOps. On your side, most of the work would be exposing a getter for the value of interest. You can also expose information such as purge users, etc. The operation is a method you can invoke on a JMX bean. Spring also supports exposing a lot of server details as management beans via Actuator. It exposes very deep metrics about the application and helps you jump right into production-ready status. I use the support for Actuator in IntelliJ IDEA Ultimate Edition that you can see on the left here. It's pretty spectacular. Usually, one controls and reads JMX via web interface tools or dedicated administration tooling. If you have access to any of them, I suggest you pick one of them up and use them as it would work pretty well. Some developers like JConsole. I didn't use it much. I've used some of the other tools and I prefer them in some cases. JMX Term is just as powerful, but doesn't include the visualization aspect. In that sense, it's exceptionally convenient when we need to understand something quickly on a server that might be alien. It's also pretty useful for getting high-level insights from the server internals. We can get started by downloading JMX-Term from the link here. Once downloaded, we can use JMX-Term to connect to a server using this code. Notice that JMX needs to be explicitly enabled on that JVM. When dealing with a production or containerized server, there will probably be some ready-made configuration. However, a vanilla JVM doesn't have JMX enabled by default. Once JMX is enabled, you should update the hostname and port based on your connection. Once connected, we can list the JMX domains using the prompt. We can then pick a specific domain to explore. A domain can be any string, but it usually corresponds to package names. Domains help us identify the group of beans in much of the same way as packages group classes together. This is where the visual tool is usually beneficial, as it can provide you with faster navigation through the hierarchy and quick assessment of the information. In this case, I just want to set the logging levels. For that, I pick the Java util logging domain. We can follow this by listing the beans within the domain. Then pick the bean that we wish to use. Since there's only one bean in the specific domain, the choice is pretty simple. I can just copy and paste the name to make the selection. What can I do with that bean? For that, we have the info command that lists the operations and attributes of the bean. Attributes provide information about the bean. Operations let us invoke a method on the bean, and we can bind notification to the bean. In this case, there are no such options. Once I have these, I can check the current logger level. It isn't set since we didn't set it explicitly, and the global default is used. The following code is equivalent to invoking the getLogger level method. It looks like I snipped the bottom of the response, but I didn't. The bean doesn't have a logger level set, so it returned nothing. Let's fix that. I can explicitly set the log level to info and then get it again to verify that the operation worked as expected using this code. Here we invoke the set logger level method operation with two parameters. The first parameter is the name of the class where the log level should be changed. The second parameter is the info logging level. This is just the tip of the iceberg. We can get many things such as spring settings, internal VM information, etc. In this example, I can query VM information directly from the console. JMX is a remarkable tool that we mostly use to wire management consoles. It's remarkable for that, and you should very much export JMX settings to your projects. Having said that, you can take it to the next level by leveraging JMX as part of your debugging process. Server applications run without a UI or with deep UI separation. JMX can often work as a form of user interface or even as a command line interface, as is the case in JMX-Term. In these cases, we can trigger situations for the debugger or observe the results of a debugging session right within the management UI. In the next video, we'll talk about JHSDB, which is an amazing tool you can use to gain insights into the JVM, even in production. If you have any questions, please use the Slack channel to ask them. Thank you.